Hello everyone, welcome back to my YouTube channel Amit Physiotherapy Classes. I hope all of you are getting benefited through my lectures. So today I am going to explain you about the topic liver. It is one of the important topic from the subject basic biomechanics. So let's start with liver. So what all contents we are going to discuss in this chapter? First, we are going to focus on the introduction part. Then we are going to see the components of the liver, then types of liver, and then I am going to give you some important exam tips by which always for your lifetime you can remember the topic liver. Then some of the important points to remember. Then I am going to explain you about load arm and effort arm, what is mechanical advantage and disadvantage, and at last I am going to use some of the examples to understand what is mechanical advantage and disadvantage. So what are the learning objectives of liver system? So what you will be able to learn after finishing this chapter? So you will be able to define liver, you will be able to explain the different type of livers. What are the livers in the real world? You will be able to identify the livers in human body, and you will be able to define what is mechanical advantage and disadvantage. So let's start. Introduction. Livers are seen in everyday life. You are going to see the liver, the types of the liver, whether it can be first order, second order or third order in every day of life, and as well as you will be using this even in the sport and exercise. So what is the definition of liver? A liver system. A liver system is a rigid bar that moves around a fixed fulcrum with two forces applied to it. So as you can see in the picture, this is our fulcrum, the axis around which this rigid bar is going to move with the help of the two forces which are applied on the either of the ends of the rigid bar, known as load and effort. So what are the different components of liver? So we have three key elements. We have three key elements of the liver known as fulcrum, effort and load, as well as we have the fourth one known as the rigid bar. We have the fourth one, the rigid bar. This is known as rigid bar. So what is fulcrum? Fulcrum is a fixed pivot point or the axis around which the movement is going to take place. So as you can see, this is the fulcrum. So it is a fixed point, or you can say axis, around which this rigid bar is going to move either in this direction or either in this direction. It is going to move. Then second one, what is effort? The source of the energy that will do the work, means the effort which you are going to apply to move the load, that is known as effort. Third, load. What is load? The weight or resistance which has to be moved by the use of the effort. So these are the important component of liver. So let's see in detail. Liver, as I have told you already, it is a rigid bar or object that moves around a fixed fulcrum with two forces applied on the either end. So what is fulcrum? It is a fixed pivot point. Now in the human body, for example, a joint is always going to considered as a fulcrum. So how you are going to correlate with the human body? Fulcrum will be always correlated with the joint of the human body. Effort, as already we know, the source of the energy which will be used to move the load. So in human body, which is going to correlate the effort? The muscles. Muscles in the body, means by the muscular contraction. And the load, the weight or resistance to be moved by the help of the effort. So in human body, a body part can be considered as load, the weight of the bone, or anything which you are holding, or the resistance, or the center of gravity, or the gravity, that is going to be considered as load. Now, what are the different types of liver? There are three types of liver, or you can say three classes of liver, known as first class liver, second class liver, and third class liver. You can find in some of the books given first order liver, second order liver, and third order, anything you can name. Now, why it is termed as first order, second order, and third order? So, the positioning of the fulcrum, load, and effort in relation to each other will determine whether it is first class, second class, or third class. What does it mean? As it is mentioned here, depending upon the position of fulcrum, which we can denote by the letter F, load, which we can denote by L, and the effort, which can be denoted by E. Depending upon the position of these letters or the placement of these things, we are going to determine whether it is first order, second order, or third order. So, this is a diagram which is going to tell, or which is going to explain what is first order liver, second and third. So, you need to remember one important mnemonic that is known as FLE, F-L-E, fulcrum, load and effort. If fulcrum is in center and load and effort are on the either end, this will be termed as first class liver. If load is in the center and effort and fulcrum are on the either side, then it is second class liver. If effort is in center and load and fulcrum are on the either side, then it will be termed as third class liver. So this was the important exam tip which you need to always remember. How you can remember? Use the mnemonic FLE, F-L-E, FLE. Write down the number 1, 2 and 3. Just below 1 and 2, 3 you write this mnemonic in the same sequence, that is F-L-E. Try to remember FLE. So F is going to represent what? Fulcrum. L is going to represent what? Load. And E is going to represent what? Effort. And here the number 1 is going to represent the first class liver, 2 is representing second class liver, and 3 is representing third class liver. So now how we can correlate this? That in first order liver, who is in center? Fulcrum. In second order liver, who is in center? Load. In third order liver, who is in center? Effort. So now if we come back to the image, it becomes much easier to understand this. Now see here, the fulcrum is in center. So first what you will do, write the mnemonic FLE, write the number 1, 2, 3. Now see, F means F should be in center. So yes, F is in center here. It means it is a first order liver. L, load. Now L load is in center. So it means it is a second class liver. By this mnemonic, FLE and 1, 2, 3. Now effort, it is correlating with 3, means effort should be in center, then only you will term it as third class liver. Okay, now coming to the some of the important examples with in relation to human body and daily life. So as we all know now, first order liver, we can write one more time the mnemonic FLE, F, L and E. You can see in the image, F is in center, here load is in center, and here effort is in center. And remaining the two things will be on the either end, either on the right side or on the left side. There is no compulsion that whether it should be on right or left, but the center part should be exactly like fulcrum should be in center or load or effort. That depends upon the type of the liver. Now, in the first order liver, you can see the example seesaw, which all of you know you have seen in the park. So this is the fulcrum. On one of the side load will be there and one of the side effort will be there. Second order liver, wheelbarrow. So the wheel is going to represent the fulcrum and the person who is sitting in this wheelbarrow is the load, and the effort is applied by this person by holding this hand. In third order liver, if you see the fishing rod, So when the person is holding the fishing rod, that part is considered as fulcrum. Same you can coincide with this image. See fulcrum, fulcrum. Now load, the fish which the person is going to catch, that will be the load, and effort is going to be applied by the rod, this part. So that is your effort. Similarly here, effort by this lady, load the person sitting, and the fulcrum, this wheel. In this case also fulcrum, this is the axis, and one side there will be load and one side will be the effort. Now coming to the human body example, first order lever, second order lever, and third order lever. In first order lever, the example is given as atlantoaxial joint. So the atlantoaxial joint is going to considered as fulcrum. As already I have mentioned in introduction, that joint is going to behave as a fulcrum. And the load is of the weight of the skull. Weight of the skull, or gravity is trying to pull the head down. Then who is going to apply the effort? The muscles, the posterior neck muscles, they are going to act as an effort, and they are going to pull this skull from from flexion to in the neutral position. Means as our head, the weight of the head or the gravity is trying to pull the head down, fulcrum is the atlantoaxial joint. So the posterior neck muscles, they are trying to pull this and bringing it to the neutral. So this you can say is an example of first order lever. Second order lever known as MTP joints of the lower limb. MTP joints of the lower limb means metatarsophalangeal joint. Now when a person is trying to do the plantar flexion, or in another way, when a person is trying to stand on the tip of the toes, then this joint, that is known as MTP joint, it is going to act as a fulcrum. The load is of the body weight. The body weight is the load, and the effort is derived by the calf muscles. The effort will be coming from the calf muscles. Here the calf muscles have their insertion on the behind on the calcaneal bone. So you can see here the load is in center, so it is a second order lever. Third example, by doing a biceps curl. So now we know in third order what should be in center according to mnemonic? E, that is effort. Now if we see in this image, the effort is done by the biceps muscle. The effort is produced by the biceps muscle, and the fulcrum is the elbow joint, and the dumbbells are the load. Now remember that the biceps is going to insert on the forearm bone. So the biceps muscle comes actually in between the elbow joint and between the load. So it is an example of third order lever. Another exam tip, very important, which can be used for PC exam and NPT also, even for normal exams also. So as you can see one of the image here, in this I am going to explain you about the third order lever example and first order of human body. So let's see this. It is important to think about where a muscle is going to attach. Otherwise, always the students are having a confusion when someone asks about the biceps muscle. They think that biceps is going to come and insert somewhere here only. So how it can be example of third order? They will never think that biceps is going to insert on the forearm part. So when they are going on forearm, the biceps, an elbow joint is the axis, and if the load is here in the wrist part, then if you see according to the mnemonic of flea, then whenever the effort is in center, it is third order. So we can see here when the person is trying to do biceps curl by holding the dumbbells, what is happening, and the elbow joint is the axis, the biceps is actually in the center in between the fulcrum, that is the joint, elbow joint, and the load. Now similarly, there is one more example which is going to be used for triceps muscle. Triceps is always considered as the example of first class lever. Now see here, again the fulcrum is what? Elbow joint. Fulcrum is elbow joint. Load is again the dumbbell, is the person is holding a dumbbell here. Now the effort, if you see the triceps muscle, which we know which runs on the posterior of the arm, is having an insertion on the oligocronal process of ulna. And if you have a proper look of the anatomical structure or the bones and the bony landmark, the oligocronal process of ulna comes slightly behind the elbow joint. Means here the oligocronal process and this is the elbow joint. So the triceps insertion is on the oligocronal process of ulna. So if now in this case, so effort is here, fulcrum is this joint, elbow joint, and load is here. Now who is in center? Fulcrum. So this is the example of first class liver. Now always remember, points to remember, very important. The human body contains all classes of liver, but which one are more common in human body? Third class livers are most common. Keep it at this, remember, a important mark you can make for Viva. Anyone can ask you which type of livers are commonly seen in human body. So always remember the third one. Neither first, neither second, the third. Now, let's discuss about what is load arm and effort arm. So, if you look to this diagram, as we know, this is the fulcrum. On one side we have effort, one side we have load, L, E, and F. So, the distance from the fulcrum to the effort is known as effort arm. The distance from the fulcrum to the load is known as load arm. Okay. So distance from fulcrum you need to check on the effort side and on the load side. Now, very important. What is mechanical advantage and disadvantage? So whenever liver effort arm is longer than its load arm, it will be said as mechanical advantage. So what does it mean? If this is a rigid bar and for example this is a fulcrum, and here we have load and here we have effort. Now if I measure this distance from the fulcrum to the effort, for example this is 3 centimeter, and the distance from the fulcrum to the load, for example, is 1 centimeter. So what does this sentence says? Whenever the effort arm is longer, whenever this effort arm is longer than this load arm, then always we will say the liver is in mechanical advantage. Now in another scenario, if this is a rigid bar, fulcrum, this is your effort and this is your load. Now if you see the distance from the fulcrum to the load, so this is what? Load arm. And from distance from the effort to the fulcrum is our effort arm. Now which is longer? The load arm is longer. So whenever the load arm is longer than the effort arm, then it will be termed as mechanical disadvantage. So remember, when effort arm is longer, mechanical advantage, and when load arm is longer than the effort arm, then it is mechanical disadvantage. So we know livers with mechanical advantage can move the larger loads with a relatively small amount of effort. And always remember another important point for Viva purpose, that second class livers always have mechanical advantage. We will see through examples. So what formula we can derive? That mechanical advantage equal to weight by effort. And if this ratio comes more than 1, then you will say it is a mechanical advantage. If this ratio of W by E comes less than 1, we will say it as it is mechanical disadvantage. Now through examples. Now in first order liver we can have 3 scenarios. As we know the mnemonic: flee, fulcrum, load and effort. So in first order liver we will have 3 scenarios. This is the first scenario, second and third. In first scenario, the fulcrum is exactly in the center, means these effort arm and the load arm is equal. So we can say this liver system is in equilibrium. Like the things which can be used like to weighing scales, measuring scales, which you have seen. Like if you go to purchase 1 kg sugar and then they will balance the sugar and the weight, so that type of liver. Another scenario. Now, if this fulcrum is closer to the load, means which arm is longer? Effort arm. And this is what? Load arm. Now, if you remember what I told, whenever the effort arm is longer than the load arm, what is that? Mechanical advantage. So in first order lever, you can see the equilibrium also, you can see the mechanical advantage also, even you can see the mechanical disadvantage also. It depends upon the placement of the fulcrum, whether the fulcrum is close to the load or close to the effort. Let's see the third scenario. Now in third scenario, the distance from the load and fulcrum, this is load arm, distance from the fulcrum to the effort, this is the effort arm. Now which one is larger? The load arm. So the load arm is larger than the effort arm, so this will be termed as mechanical disadvantage. So what you came to know, that in first order lever we can have all three scenarios: equilibrium, mechanical advantage and disadvantage. What you need to remember? The placement of the fulcrum. Second order lever. In second order lever, we know, according to the mnemonic, who should be in center? Load. So yes, load is in center. Now you see here, the distance from the fulcrum to the effort is larger and the distance from the fulcrum to the load is now smaller. And one more thing to remember, if you move this fulcrum here also, still which one is larger arm? Effort arm. So always the second order levers are in mechanical advantage. They can never go in disadvantage. Third order. Now, according to the mnemonic, we again know who should be in the center? Effort. So yes, we have effort in center. Now see the distance. The distance from fulcrum to the load is larger now compared to the distance from fulcrum to effort. If I move fulcrum here also, still the distance from the load and fulcrum is larger as compared to the distance from fulcrum to effort. So whenever the load arm is larger than the effort arm, it will be termed as mechanical disadvantage. So what conclusion came? That first order lever can be defined as equilibrium, mechanical advantage and even mechanical disadvantage, depending upon the three scenarios. Second order lever always goes for mechanical advantage and the third order lever always goes for mechanical disadvantage. Thank you so much for listening. Please like, share and subscribe. Thank you all of you.